Hello everyone, this is Navneeta. Now we are going to study the topic from reflection of light by plane surfaces. That is, formation of an image by a plane mirror. So here we are going to observe the formation of an image by a plane mirror. So case 1. Okay, so point object. So observe this figure carefully here. Here O is a point object. Okay, so some rays from O, that means at the point of object, reach the mirror. So you can see here, these are the rays are coming from the point O and reach the mirror at some points. So here some rays from O reach the mirror and get reflected. Yes, this is the mirror here. And this is the reflecting side and this is the coated side. Okay, here. When we look into the mirror, the reflected rays seem to be coming from the point I. Okay, when we look into the mirror, the reflected rays seem to be coming from the point I. So here, point I is the image of point object O. Here I is the image and O is the object. So here I is the image of point object O. So here observe the distance of object O and image I from the surface of the mirror. Okay, and try to compare these distances by approximate estimation. So if we find that these distances are equal. Okay, so here the distance from point O to mirror and the distance from mirror to image are equal. Okay, so case 2. In this case 2, let us assume that an object O dash. Okay, so here this object O dash is kept in front of mirror. Okay, this is the front side of the mirror and this is the back side of the mirror. So this back side is a coated part, right? So here O dash is object and it is kept in front of mirror. And draw a few incident rays from the object to the mirror. Okay, so here these are the incident rays. Okay, so here draw a few incident rays from the object to the mirror and reflected rays from the mirror using laws of reflection. Yes, here these are the reflected rays. So in this figure, the rays coming from the point O, here the rays coming from the point O get reflected from the mirror, right? So and seem to be coming from the point I. Okay, so here these rays are seem to be coming from point I. So we say that I is the image of O. Okay, and the rays coming from the point O dash, right? So the rays coming from the point O dash get reflected from the mirror and seem to be coming from the point I dash. So we say I dash is the image of O dash, right? So here the rays coming from the middle part of the O and O dash will form their own images between I and I dash. Okay, so when the rays coming from the middle part of this O and O dash will form their own images between I and I dash. So thus I and I dash is the image of O and O dash. Okay, here I and I dash are the image and O and O dash are the object. So we can say that here I dash is the image of the object, O dash. So here, what is the size of the image compared to the size of the object? Right? So here, when we compare the size of the image with the size of the object, here the size of the image is equal to the size of the object. Okay? Here the size of the image is equal to the size of the object. Now, what are the characteristics of this image? Okay, so let us discuss some of the characteristics like size, distance and right-left inversion of an image formed by a plane mirror. So here these characteristics of image formed by a plane mirror. So here, when we compare first of all, we need to take an object. Okay, so take an object, say pen or pencil. Put it in front of a plane mirror. Okay, touching the surface of the mirror. So what do you say about the size of the image compared to the size of the object? Right? So when we put a pen or pencil in front of the plane mirror, which is touching the surface of the mirror. So here, what is the size of the image compared to the size of the object? Now, move the object towards your eye. What do you observe? Is the size of the image decreasing or increasing? Here, for this question, what do you say about the size of the image compared to the size of the object means? When we compare the size of the image to the size of the object, there is no change in size between the two. Okay, there is no change in size between the two. Yes, so when we move the object towards the eye, yes, so here is the image, size of the image decreasing or increasing means, here when you move the object towards your eye, you observe the size of the object is increasing at your eye. Okay, here the size of the image is increasing at your eye, then the size of image in the mirror is decreasing. Okay, when the pen or pencil moves towards your eye, there will observe increase in the size of the object at your eye, and you will also observe decreasing the size of the object in the mirror. Now, here this figure 10 shows the formation of an image by a plane mirror. So in that figure, you might have noticed that the size of the image is equal to the size of the object. Why does the size of the image seem to be decreased when you move the object towards your eye? Right? So to understand this, see this figure which shows how your eye judges the size of an object. So here, observe here. Observers 1 and 2 are looking at the object which is at point O. Okay, here is the object at point O. Okay, so here observer 1, here observer 2. Okay, so observers 1 and 2 are looking at the object which is at point O. So it looks smaller to the observer 2. Okay, so here is the observer 2. Here is the object, right? So to this observer 2, the object is very small. And to the observer 1, here this looks like smaller to the observer 1 than observer 2 than observer 1. Because here the light rays coming from the object make a smaller angle at the eye of observer 2, who is a larger distance compared to observer 1. You can see here. So here from this point O to observer 2, when he observed from this point, here this object makes a smaller angle here when compared to this observer 1. Yes, so here the angle plays a role in judging the size of the object. Okay, so in the same way, when we move the object from the mirror to our eye, the image in the mirror seems to move back in the mirror. Okay, so then the distance from the image to our eye increases. Okay, so the angle made by image at our eye is smaller than the angle made by the object. So that is why the image looks smaller than the object. So assume that this is the image and this is the object. Okay, so here think that this is the eye point. So when we bring the object very near to our eyes, here the object size increases and image size will be decreases. Okay, so here when you stand in front of a mirror, you might have observed that the distance of your image in a plane mirror seems to be equal to the distance between the mirror and yourself, right? So when you stand in front of a mirror, you will observe that the distance of your image in a plane mirror seems to be equal to the distance between the mirror and yourself. Okay, here the distance between you and your image is equal. So what you observe is generally true. So here we can verify this by observing figure 10. So there we got the distance from object to image is equal, right? So here also same reason. Okay, so you also might have observed the right left inversion of your image in plane mirror. Okay, so why does an image suffer lateral, that means right left inversion, right? So here the light rays that come from our eye, okay, the light rays that come from our eye get reflected from the plane mirror and reach our eye. Okay, here the light rays that come from our right eye get reflected from the plane mirror and reach our eye. So our brain feels that the ray is coming from the inside of the mirror. So as a result, our right ear looks like left ear in the image. So this is called lateral inversion of an image. So you can observe this figure. Okay, so here the light ray which comes from our right eye. Okay, so here the light ray coming from our right eye. and it get reflected from the plane mirror, okay, and reach our eye. Our brain feels that this reflected ray is coming from the inside of the mirror, right? So that is why our right ear looks like left ear in the image. So what do you understand from the figure 12 here? So here we understand an image suffers lateral inversion, that means right left inversion. Now observe the lateral inversion of a letter with a ray diagram here. Okay, so here think of the process of image formation by a plane mirror and explain lateral inversion by observing this figure. So here the light rays are coming from this point J. So here assume that O, this is the O dash, this is the object here, okay, and here this is the I dash. Okay, so the rays coming from the point O, right? So here the rays are coming from the point O. These are the incident rays and these are get reflected back, right? So here these rays are appear to be coming from the inside of the mirror, that means point I. So we can say that here I is the image of the point object J, and here the rays which are incident from the point O dash, that means this is the object J. So these are reflected back like this. So when we observe these reflected rays, so these are appear to be coming from the inside of the mirror. So this is the I dash, assume that. So here I dash is the image for the point object O dash, right? So here the distance between this image and object are equal. Okay, so that's why here due to this an image suffers lateral inversion. So here you can observe this figure 14. Here are arranged some Telugu English alphabets in front of a plane mirror and observe the images here, right? So here we observe the lateral inversion here, right left inversion. Yes, here uses of plane mirrors in our daily life. Plane mirrors are used for dressing purpose of ourselves. Plane mirrors are used for decoration on walls of some shops like jewelry shops, sweet shops, barber shops, etc. So to observe the shop in all directions and to get multiple images of things and persons. Okay, and plane mirrors are used in making some optical instruments like periscopes, etc. Okay, and some type of solar cookers are made by using plane mirrors. Okay, so this is about reflection of light by plane